All right. Here we go. Wait for a couple people to join in. And you know what? Let's send the share link out on Facebook. Right, so hello everybody. Feel free to post in the chat. Oh, hello Sean. All right, and we'll start at about 11:05. We will get going with our show for today. We're talking a little bit about some Babylonian astronomy, along with dark skies preservation with some of the stuff that we've been doing here at GLAS. And after that, we'll be going through and looking at some cool stuff up in the night sky. Ooh, we already got a question in. Has every major culture have its own names for stars? For the most part, I believe so, yes. Some of them kind of overlap depending on, which culture adopted which. A lot of the Arabic names for stars have survived for well over a couple thousand years now. Kante, do you have any input there for what names of stars in different cultures? I think for the most part, most cultures tend to have their own names. Sometimes they can have kind of the same origin, meaning-wise, if they're relating to a story or some kind of characteristic.
Yeah. And yeah, like you said, a lot of names for stars that we have even now are still can predate back to a lot of other ancient cultures. Like a lot of stars that have the prefix al in them are probably Arabic in origin.
Ooh, I like seeing some Spanish in the chat room, especially when
Yeah.
I understand it.
Same.
Right, but 1 minute to showtime. Oh, I say that as it turns 11:05. Okay. We are going to get started very, very soon. I think what I'm going to do is I'm just going to jump into the introductions then. So thank you guys all for joining us tonight. If you have not joined us before, if you're unfamiliar with GLAS, welcome. My name is Adam McCulloch. I am the Planetarium Specialist here at GLAS Education. And since we are not allowed to have large public gatherings, it kind of makes it hard for us to have 20 people inside of a planetarium within 6 inches of each other, much less 6 feet of each other. So we decided that we wanted to have something online so that people could come and learn about the night sky in a way that is safe and also comfortable for everybody, because we can all do it from the comfort of our homes. Part of why we're doing this show so late is because we want to be able to observe, and the telescope we will be observing with is in California, so it is just now beginning to get dark for them. And so now I want to introduce my wonderful co-host, Katya Gosman, who is an undergraduate student at UChicago, and she is our professional astronomer here, so she will keep an eye on the chat along with Kate Meredith, who is the president of GLAS Education, and they will answer all of your questions that you have along the way while I do my rambling. Katya, anything you want to add to your introduction?
No, that was great, Adam. Thank you.
Good. Well, that we are just going to start right off. I like to start every planetarium show by getting people a little bit more comfortable with looking around the night sky. And sometimes watching one planetarium show and seeing how to find the North Star isn't always enough, so I'm going to do it every time at the beginning of the show because I think it's something that's useful, and the more you hear it, the more likely you are to remember it, and that way when you go outside, you can actually look and find stuff on your own. So now you can look between both of us and watch the night sky. And right now we are using a program called Stellarium, which is a free planetarium software that you can actually download and use yourself. There's also a web version if you have a Chromebook and can't download anything. So just Google Stellarium. It's spelled exactly how it sounds. And you guys can explore the night sky with that. Right now we're just gonna kind of take a look around. One of the nice things that Stellarium does is it already highlights some of the brighter stars in the sky. It also puts cardinal directions around the horizon so you know which way you're facing. Now, you're not always going to be able to know which direction you're facing, because when you go outside at night, there aren't big red letters floating on the horizon telling you. So we're going to just get rid of those for now because I want to show you a trick that you can use for yourself. Right now, there's also a very nice bright comet, Comet Atlas, up over near lower in the horizon, but we want to find north. And once the cardinal directions are gone and you kind of spin around a little bit, if you're not too familiar with the stars, it can be very easy to get lost. But one thing I want to show you is to always look for one specific constellation first and foremost. And that constellation's name is the Big Dipper. And so we're actually going to just zoom in a little bit on here and highlight it. So you can see that there's actually more to it than just the Big Dipper, and we'll get into that in just a minute. But right now we're going to zoom in and we just want to look at the Dipper part of this. So as you can see, we have the cup, and I'll highlight stars along the cup. So we have the 4 stars of the cup. And then, of course, with any spoon, you kind of need a handle. So there is the handle of the Big Dipper. Now, the Big Dipper is really good to find first for a couple of reasons. The first of which is that the Big Dipper has 7 stars in it, and they're all fairly bright stars. One is a little bit dimmer than the other 6, but for the most part, it's very easy to pick out the Big Dipper, even if you're in a kind of a light polluted area. And that is another thing that we'll be talking about a little bit later on in the show. And so finding the Big Dipper is very useful. And another good thing about it is that it's actually always up in our night sky. So no matter when you go outside, you can always go up and go look out and find the Big Dipper. Now, one of the reasons that you want to find the Big Dipper is that you can actually use it to find something else very important in our night sky. So if you take the far side of the cup, so on the opposite side from the handle, use the two stars, Merak and Dubhe, and you connect those into a line, and you kind of extend that line down until you reach a star named Polaris. Now, if you have not heard of the star Polaris, you probably know it by a different name, as Polaris is also known as the North Star. Polaris, obviously, is a very important star for us because being able to find north is a very useful tool. Because once you've found north, you can use that to find your other three directions. As long as you always remember to never eat soggy waffles, you can remember to always know it's north, east, south, and west. So then you can kind of orient yourself in the sky that night. So finding the Big Dipper and then Polaris is extremely useful. Now, one thing I want to talk about before we jump into Babylonian sky culture and go a little bit back in time is that the Big Dipper is actually not a constellation all on its own. The Big Dipper is actually part of a larger constellation named Ursa Major. And Ursa Major is, as you can almost kind of tell by the shape, a big bear. So we'll turn the pictures on because the constellations don't always look like what they're supposed to. And my head might be in the way a little bit there. So we'll move, and as you can see, that makes sense with the Big Dipper being a big bear, that the Little Dipper is then a little bear. And so these are kind of the two main constellations that you can go out and find here. And I'll explain in a little bit why the Big Dipper is something that is always up in the night sky. And it will make sense when you understand that Polaris is kind of the central part of where the entire sky rotates around. One thing that I wanted to point out is that as we look up in the night sky, as you can see, part of the night sky is actually fairly blank. The more you look around, there seems to be kind of a grouping of bright stars. Every here and there you see some bright stars, but it hasn't always been that way. Even here in Williams Bay, you can actually see that the observing location where we are currently at, we are observing from Yerkes Observatory, so we're able to observe locally. There's still light pollution out here. We actually still get some of the light pollution from Chicago and Milwaukee and even the local towns around here. And we'll be talking about how we can actually help and reduce that to have darker skies for when we do observe here around Yerkes. But the ancient Babylonians, who existed 2,000 to 3,000 years ago, didn't have to deal with light pollution because there weren't city lights on at night. At most, they had fires, but they usually did not try to sustain those all night because that's kind of a waste of resources. So we're actually going to take light pollution away and increase kind of the darkness of our night sky. And so as you can see off in the horizon, the Milky Way is beginning to rise this time of night. And some of the stars there in the Milky Way. But we are going to take these constellations down because even though Ursa Major and Ursa Minor are very old constellations, they were not how the ancient Babylonians saw them. They had their own constellations in their place. So we are going to now switch over and use the Babylonian constellations. So we'll start kind of right where we were earlier. Here we have the wagon. And actually, before I get started, I have one other thing that I need to do. First, looking at what the ancient Babylonians saw from Wisconsin does not make a whole lot of sense. So we are going to go just somewhere off over here and end up somewhere in Iraq. That should work right about there. And another really cool thing about Stellarium is that we're also able to go back in time. And to go back over 3,000 years, you just put a little negative number in front of that there. And oh, now you can see that the sun is actually up because we're on a different part of the world at the time it was when we were in Wisconsin. So now we're just going to fast forward to night. And now we have basically the sky that was up, but now we are all the way in ancient Babylon, looking up at the night sky. So a lot of the stars are actually still highlighted here, and you can see they all have different names. And all of the planets and stars, the bright stars at night, were usually named after different gods in their own mythology. So for the Babylonians, the gods were usually represented not only in the stars, but also on Earth, typically in the form of a large statue, and each city in Babylonia had kind of its patron god, where that was the main god that was worshipped there. The main god for Babylon, the capital city, was Marduk? I'm already blanking on the name.
Marduk.
Marduk, thank you. Now, I want to talk a little bit about some of the constellations. So, the Big Dipper was actually a wagon for them, and there was a reason for this. Because Polaris, we have to change one quick setting. Because instead of bringing up each constellation at one at a time, we just want to bring them all up. So we can kind of scroll through the sky and look at the different things that they used to pick out in the night sky. So for them, they had 2 wagons up in the night sky. And if you see some of the random names like Fox or Iwe, something like that, those were 2 of the different gods represented by a single star, even though those stars were in a constellation that actually had its own story and meaning. And so down here we have the hitched yoke. If you're not familiar, it's kind of that wooden thing that you kind of put 2 oxen or 2 bulls together, and that would pull the cart. And the part of the reason that the hitched yoke is here is that you can see off here is the wagon of heaven and the wagon. And if we go forward in time, and since I have the sky turned off, you can see that these all kind of go around in a big circle. And so the sky all kind of appears to rotate around the center. And the center of this big grid that you're seeing up here, in modern day, is where Polaris is. But due to the precession of the Earth, Polaris has not always been the North Star, and therefore the kind of center, or the kind of the top of the celestial sphere. But due to precession 3,000 years ago, Polaris was actually over here in the hitched yoke and had the name of the son of Anu, who was one of the really important gods. So this is Polaris. So Polaris, unlike today, where it stays basically still, Polaris actually moves around the sky in a big circle. So they believe that they had the wagon, the hitched yoke, and the other wagon of heaven, which is actually the head of Draco in modern astronomy. So let's move back into night. into the early evening, where everything kind of was before. There we go. So we have the hitched yoke and the wagon of heaven. And I want to talk about some of the other constellations that either related to certain gods or are very similar to the ones that we actually still have today. So down here, the Scorpion is actually the same constellation as Scorpius. So one of the zodiac constellations, Scorpius, has been a scorpion for a very long time. And a lot of the constellations that we view today come from the Greek stories and astronomy, which had many of their origins in Mesopotamia and specifically in Babylon. So that's why when I point out a couple of these things, there actually is going to be quite a bit of overlap. Up here we have the scales representing one of the kind of justice during kind of their reign, and the scales also uses part of the constellation Virgo and part of the constellation Libra. And if you're not familiar, Libra is actually represented by a scale representing justice. So you can we know that this constellation scales came from Libra, came from this constellation that the Babylonians had. Down here,
another thing.
Oh yes, go ahead.
Oh, just another thing about Libra and Scorpius. Another, I guess, interpretation that some historians or whatever have said is actually that the scales, Libra, were often considered by Mesopotamians to actually be the claws of the scorpion, so of Scorpio. Fun fact. And actually, the Arabic name for the two brightest stars in Libra happen to be the North Claw and the South Claw. Fun fact.
Yes. So the scales in here use the only part of Libra. So then it would make sense if this star here is actually part of the constellation Libra. So this was the top claw, and this star also part of the Libra. So these were the two stars that are in modern day Libra, but were the top claws of the Scorpion. Some of the other ones that are very similar, Mushusu, the name is shortened here, but Mushusu was a snake god and actually used the same constellation lines as Hydra, so then that one kind of follows along. Here, the raven is modern day Corvus, which was a crow, so not quite the same bird, but basically the same. And if you look down off on the horizon, we have the Great Twins, which actually use the stars that formed the Gemini twins. So sometimes these stories were just kind of slightly tweaked later on to help fill the mythology of newer religions that came along and replaced ones that existed in Babylon. Also, the crab uses the same stars as Cancer, which was a crab in Greek mythology. Up here in the constellation Leo is Urgulu, the demon, was also represented by a lion. And Regulus was the king star. So that was a very important star for them, representing the king. And it just kind of goes along with how lions have been very much viewed in a kingly manner for a very, very long time. And so a lot of the constellations that we can see have for a long time been important, and we can actually get rid of the ground and look at some of the constellations that are below us. Some of the ones that are kind of fun is over here in the sun, where the sun is right now, is currently in our constellation Taurus, the bull, and even in Mesopotamia and Babylon, Taurus was seen as the bull of heaven. Also, the shepherd of Anu was one of the really high-level gods, kind of one of the main and most important gods in their culture, representing here using the same stars that represent modern day Orion. And one of my favorite ones that I find kind of interesting, over here we have the Crook. And it's not a very part of a very well-known constellation, but it's part of the constellation Orija, which is actually a herdsman. And so in Babylon, it was actually just the Crook, so just kind of being his staff as opposed to being the full constellation of a herdsman. So we see a lot of the ties in here. Another thing that these ancient astronomers did was give us kind of the start of what became the modern zodiac. But the modern zodiac uses actually where the sun moves in our sky. The ancient Mesopotamians, however, actually used the path of the moon, which the moon actually follows a very similar path as the sun, as it virtually follows the ecliptic. So now we're going to turn on the path of moon. And you can see that the path of the moon follows along. Oop. Oh. Got too many on. There we go. So now we can see just the path of the moon. And as you can see, the moon travels through our night sky apparently as it's kind of going around in its orbit around Earth. And here you can see where the moon is traveling through certain constellations. Later on, they decided, originally it was 17 constellations that the moon traveled through over the course of a month. Later, they decided to break that down and do it over the course of a year and have 12 constellations, each taking up 30 degrees of the sky, which then adds up to 360, making the full circle throughout the night sky. And we believe that actually led into the modern day zodiac. Now, one thing I want to point out is if you notice above the moon, this big cloud that seems to pass right through our sky. If you've never seen this before, you are actually in the majority of Americans because light pollution prevents us from actually seeing the arm of the Milky Way in our night sky. And so this is all of the gas and dust that's in our galaxy that we unfortunately usually cannot see because there's too much reflected light in the night sky. And this brings me to now, I would like to introduce some of the students that have been working with us. They've recently taken over the Geneva Lake Dark Sky Initiative Facebook page and soon the website. So we are trying to get another push for dark skies in our local community. And to introduce those students, I want to welcome in Kate Meredith, president of GLAS Education.
Hi, I hope I have finally managed to join the correct chat room, and I wanted to say hello and welcome all the people who are part of the effort tonight. We've got Melena and Edward and Jack. And I am going to introduce them. So Edward is from Niles West High School in Skokie, and both Melena and Jack are from Badger High School here in Walworth County and Lake Geneva. We've been working for months to increase public awareness for the importance of dark skies in the Lake Geneva area. And they've been working as part of this project for quite some time, and they're going to share with you just some of the things that they have learned. But we're looking forward to seeing you join us, watching out for our Facebook page and liking the Geneva Lake Dark Skies Initiative. So with that, I'm going to pass things off to Edward and he can get things started.
Hi, I'm Edward. I'm from Skokie, Illinois. And when we think of pollution, you think of waste like in our ocean or smog that comes from factories like in China and India. Never in our daily living do we think about how detrimental light pollution is to our natural life. As light pollution gets worse, amphibian populations are declining. They're an important part of the ecosystem, being indicators of its health. Many animals depend on nighttime for their reproductive cycles. For instance, frogs and toads croak at night as part of their reproductive ritual. Light disrupts the ritual because the frogs do not know when it is time to croak. Frogs and toads have been known to cease their mating activities altogether in areas where light pollution occurs. Another example of this is when sea turtle hatchlings orient to brighter light at the horizon of nighttime. With lighting from cars and hotels along the shores greatly reduced during stay-at-home orders, many more hatchlings are finding their way to sea. Now, how does blue light affect us? According to the American Medical Association, blue-rich LED or white street light, um, I'm sorry, blue-rich white LED street lighting is 5 times more disruptive to our sleep cycle than conventional street lighting, and brighter residential nighttime lighting is associated with reduced sleep, reduced melatonin, a shift in circadian rhythm, and impaired daytime functioning, and a greater incidence of obesity, diabetes, and possibly cancer. Blue light can be harmful not only to us, but to our skies as well. Limiting your nighttime exposure to electronics could prevent blue light damage, and you can limit damage to our skies by using fixtures that minimize glare or low pressure sodium lights. Um, Now here are 3 quick solutions to help reduce light pollution that you can do right now. The first one is to change to dark sky friendly features. Open and unshielded light fixtures add extra light that is not beneficial to your yard or the sky. You could look for fixtures that minimize light trespass and glare. I'm going to hand it off to Melina now to talk about the second point.
Hello. Another way that you could help reduce light pollution is by turning off any unnecessary lights. For example, you can put your lights on a timer, remove bulbs from fixtures, and you can also turn off any bedroom window lights that affect your circadian rhythm. Next up, we have Jack Adams.
You having a technical difficulty somewhere? Jack talking but a bit muted.
Can you hear me now?
Yes.
Sorry about
Can you
that.
hear me now?
Yes.
Sorry about
Can you
that.
hear me now? Well, the last tip we have for reducing light pollution is using lower temperature
Well, the
bulbs.
last tip we have.
These are the bulbs that are about 3,000 kelvins or lower and
These
cast
are the
more red or
bulbs
orange
that
light.
are about 3,000.
As Edward
kelvins
mentioned
or
earlier,
lower
blue
and
light
cast
is the
more red or
worst and
orange
most
light
dangerous
are
for the health of
about.
people.
As Edward mentioned earlier, blue light is the worst. As Edward mentioned earlier, blue light is the worst.
Sorry, Jack. I think we might have to cut you off. Does somebody else want to step in quick and fill in? I'm not sure what's going on with the audio there.
Sure. A final tip that you could do to help reduce light pollution in your home is by using lower temperature bulbs. The warmer the hue, the more environmentally friendly the light is. This means that we can use less light in a dimmer light, creating less light pollution, especially if things like fixtures aren't there.
Right. Well, thank you guys for coming on and talking a little bit about some of the tips that people can do to help reduce some of the light pollution in their local area. We actually have a little bit of time right now that we've got to fill because the observatory is currently running through its focusing routine. And so we are gonna jump back into Stellarium for a little bit until we get the all clear for that. Unless if there's anything else you guys want to jump in right now with dark skies related, please feel free to do so. Oh, one last thing. Also, Kate is going to put into the chat room a link for you guys to go and like the Geneva Lake Dark Sky Initiative. Edward, Jack, and Melina are three of the wonderful students that are working on improving our social awareness through Facebook and Twitter and all the other social medias that I don't bother doing. But hopefully we can get you guys to follow on a bunch of those, and you can learn about all of the really cool things that we're doing and all of the things that you can do in your own backyard to help out. But with that, Katya, would you like to rejoin me?
Yes, hello. I am back, I think.
I think so.
All right.
So there's one other thing that I wanted to talk about that I found was kind of an interesting story. So the ancient Babylonians were very much into reading the night sky, given by the culture that basically invented the zodiac. And so they would look for to the night sky and read it for different signs. One of those signs was a lunar eclipse, which was actually a very bad sign for them, and a very specific sign. A lunar eclipse would actually mean that a king was going to die. Now, typically, these omens, when they read them, only were good for about 100 days. So if 100 days went past and the prediction didn't come true, it means that either your prayers or sacrifices or your actions were enough in order to break free of that outcome, and you were able to then change it. One of the things that they used to do whenever there was a lunar eclipse, one solution was kings would pick somebody from their kingdom in order to become the new king. And so they would hold a big ceremony. Everybody would have to refer to this new citizen as the king. And the real king, would go off and hide, and would even not be allowed to be referred to as my lord, but as to my lord farmer. Meanwhile, the new king would be called my lord, and he would be paraded around the kingdom, do all of the daily public duties of the king. And sometimes the king would just go sit and wait in hiding for 100 days, and after that 100 days, if nothing bad had happened, he was able to then come back out and proceed being king, because they were able to take the necessary actions to avoid that fate. Sometimes, however, though, ancient kings were not the nicest people, as I'm sure will shock none of us, but they would get impatient and usually just have one of their servants make the prediction come true for the new king after only a couple of days, so that they could go back to being king right away and not have to worry about that omen any longer. There was actually one time, though, where one of the kings did this. He brought in a new puppet king, or replacement king, and when he was off hiding, actually ended up dying from something that was in a bowl of soup. So even though he tried to avoid the omen, apparently it was just the wrong actions to take, as he ended up dying, and the person who was the replacement king actually ended up just staying in his spot and became the real full-time king. So talk about a lucky job. Now, those omens were usually seen as things moving in the sky in a peculiar manner, sometimes where planets would align with certain stars or other planets, or specifically the moon. And as we know, the planets don't have very similar orbits in our sky relative to some of these stuff around us. And I believe, Kata, you have something about that with the planets, right?
Yeah, so in general, so the ancient Babylonians, a lot of their astronomy was focused around mapping and finding the positions of various planets and stars. And so they would observe these and write these down onto these clay tablets. And so these tablets, we found some that are called the mulapin. And these are tablets that had a whole bunch of different things on them related to astronomy. So different observations, like celestial happenings and all of that stuff. And so a lot of things that they would do, for example, is observe how planets move in the sky. And interestingly enough, you have a planet like outside of the orbit of Earth, so like an outer planet, quote unquote, as they called it, or a superior planet, such as Mars or Jupiter. You could actually see its orbit do something called retrograde motion, which like some of you might have heard this term in reference to like modern day astrology, where you're like, oh, Mars is in retrograde and this means XYZ. But the Babylonians actually went and they plotted, they could at least plot out or write down the different positions. And so they would note that sometimes what that means is the planet seems to be moving backwards in the sky. So it would kind of take a path and then it would double back and make this little like loop in the sky. Which actually you can visualize with Stellarium.
That's what I was trying to set up, but it appears it wants us around a lot.
That's okay. While Adam is trying to figure that out, I can also tell you, so he mentioned Marduk. Marduk was like the patron god of Babylon. And so there's a story that Marduk, he basically, in order to create the sky, there was another god named Tiamat, and Marduk went and split Tiamat's body into two parts. And so half of Tiamat became the heavens and the other became the seas. And so land, in this case, in Babylonian mythology, was almost enclosed in a hollow sphere of liquid. And Marduk was really powerful, and they thought that he was actually the reason why constellations, for example, set and rose, and he kind of created the order that existed in the heavens. Yeah.
An idea.
Yeah, you have something.
So we'll focus on Mars. And moving one day at a time, you can see how Mars moves relative to the other constellations. And we'll turn the ground off so that doesn't become an issue. And as Mars continues to keep going and going, focus. Natu, did you want to tell a little bit more about what's behind you? So we will have to work out how to better show retrograde motion here in using Stellarium. Unfortunately, I tried looking and there were no scripts retrograde. That was
there is a way. I just haven't done it in a long time.
It's a very easy thing to do in Starry Night, which is the Planetarium software that we use in the portable planetarium. Not as simple a thing here in Stellarium. But basically, if you were to kind of plot out the path of Mars over the course of many months, you would notice that Mars tends to make kind of these little loops. And you would just kind of expect a straight line kind of throughout the sky, but really what it'll do is it kind of makes a straight line, and then we'll create a little loop, and then continue in a straight line, and then create another little loop. And I believe it's usually once every 2 years? Not yet? Or once every year, right?
Or
For retrograde motion?
I don't remember the exact number.
Yeah, so
Also, fun fact, the Babylonians used a sexagesimal system, unlike our base 10 system, so their calculations are hard to read. Yeah. I've actually gotten the chance, there was a class at U Chicago that one of my friends took, and I got the chance to look and see some of their like transcriptions of the tablets that they had and the calculations that they did.
Oh.
Yeah.
I did see it. There, if you go and look, you can actually find the numbering system for the Babylonians, and it is quite interesting. The different symbols that they used and how they tallied them up, essentially.
Mm-hmm.
One of the interesting things that I found was that the Babylonians, the way that they broke up their months, they had 12 months a year, and each month was 29 or 30 days. But one thing that they noticed is that by going through this calendar, things started to get a little off. Because if you go through and you add up 29 to 30 days over the course of 12 months, you end up around 11 days short of a full year. And so they had to, every couple of years, insert a new month in order to get everything back on schedule. And that was just their system, was to have their 12 months. And then once everything was off enough, the astronomers then would make the decision to insert an extra month. So being an astronomer in ancient Mesopotamia was kind of a full-time job. You were constantly watching the night sky, looking for different omens in order to know how civilization would continue and to be able to avoid any big disasters. Meanwhile, you were also going back and looking at all of the old clay and stone tablets in order to look for patterns to help you predict things that were coming up. And you also had to let people know what time of year it was. They created different tools. In Mulapin, which Katya talked about earlier, there are also there's also a list there of how much water you need in the water clocks that they would use in order to tell the time of day, depending on the year, because as the time of day changes, the amount of water in the water clocks has to change as well. So that was something that they kept a meticulous record of. And one other thing I want to talk about, so we can put in here the ecliptic now. See how the ecliptic, since they were a little bit closer to the equator, almost goes straight overhead. And a lot of these constellations that you can find along here, where the path of the moon was, and you can see over here, the moon, not very far off from this line, which is the path that the sun appears to take throughout the sky over the course of a year. A lot of these are the same constellations that make up the modern zodiac. So here, for Gulu, the demon is Leo the lion, Cancer the crab, the Gemini twins. Then you have Taurus bull and swallow. Let's see what comes that part. Oh, that's part of. There's Aries, where the moon is currently, And by currently, I mean in 1298 in January. So, not currently as in tonight. But then this one is of where Pisces is. So they use the moon in order to create the zodiac instead of the modern interpretation of looking where the sun was. And they did take note of not only where the moon was and where the sun was, but also where all the planets were when somebody was born. But they didn't use them originally to give predictions. It was more of something as a note that they most likely would refer to later. Or at the very least, their predictions and the omens that they saw were not written down. So back then, you would know where the sun, moon, and all of the planets were on the day you were born, as that was something they viewed as important to record. Now,
So, Adam, I have figured out, I've remembered now how to show the motion of planets in the sky in Stellarium.
ooh, how do you do it?
Yeah, so if you go down to astronomical calculations window on the left hand menu, and you can go to ephemeris, and then from ephemeris you can choose a celestial body. So if you chose like Mercury or Jupiter, and then you can click the dates that you want it to. So if you pick like a year or 2 years or something, and you can click a time step, and then you want under show to have highlighted line and markers. You can also highlight dates if you want, and then if you click calculate ephemeris, it'll show up as like a line in Stellarium.
Uh-oh. I think it's just calculating it. But it looks like I think Stellarium be deciding that time for the Planetarium show to be over.
Oh, you don't need to go that far into the future. You only need to go like a year or two into the future.
I think I only did 2 years.
Oh,
2019.
did you?
Oh, I see.
No, you went to 9,900 and
I
something.
read it as 1998 instead of 9,998. Yeah, it's gonna be a thick line with a lot of circles. So, Katya, do we have news on the Stone Edge Observatory?
It's calibrating.
Still?
Yes, still. I am currently looking at the channel that shows me all of the images, and it has still trying to focus the telescope.
Yeah. So I think we are going to go and we're going to go look at Itzamna and take a little tour of that.
Yeah, we could talk about the telescope a bit. Also, Sean had a question in the chat.
What was the
Is there any one location on the planet you could stand and be able to see all the stars and constellations that there are to be seen from Earth over a 24-hour cycle?
If you were to take the sun away,
Yeah.
then yes, at the equator. But unfortunately, the sun is always going to be in something and blocking it from our view. But that actually kind of relates to earlier this year, back in March, or I guess the first day of April, we did what's called the Messier Marathon. And the Messier Marathon is looking at a whole bunch of deep sky objects with the telescope. And there's only a time in March where the sun doesn't block any of them. And so that's a time of year where you can actually then catch all of those objects. So that kind of relates to your question of just, except in the equator, without the sun, you would be able to see everything in the sky, except Polaris would be really, really low off to the north, and therefore really difficult unless you're standing with a very low horizon that direction. Then you would be able to see that. All right, so Katya, would you like to introduce us to the Stone Edge Observatory and the telescope that we're going to be working with tonight?
I would love to. Yes. So, Stone Edge Observatory is an observatory in Sonoma, California. And as Sonoma, you might know it as wine country. It is actually located inside a vineyard. It's pretty cool. And so it's a privately owned observatory that we very nicely have a lot of access to. We have students from all over the world using it. We have groups from different parts of America. We have groups in Sweden that are using it. Yeah, anyone basically can go and ask us if you want to use that. If you want to use a telescope, let us know. And so it is a 20-inch reflector, which means it uses mirrors instead of lenses. It's a Ritchie Chrétien design. One of these days I'm going to pronounce that correctly.
It's a hard one.
Yeah. And the great thing about it is that it has, it has a very nice CCD camera attached to it. And as I'm saying that, the focusing just ended, which is fantastic. Which means I can start opening the observatory once it exposes itself. Yeah.
Katya, do you want to explain what you're doing?
Oh, yes, I will. So this telescope has a whole bunch of also different filters that we can use to create some color images, which are really cool. So right now, I think the observatory is still closing itself. I'm going to let it do that before I open it again. The focusing script is like an automatic thing that the telescope can run through, and someone initiated this like half an hour ago. And so it basically helps us better pinpoint our observations and focus our images to make them as clear as possible. And so right now what you're looking at on the channel is you see we have open, this is actually Slack. And there are these amazing people that have created and written a program in order for you to be able to interact with the telescope through Slack using a command line type interface, which basically means there's a series of commands that you can tell the engine. So it's called Itzamna, named after the Mayan god of the sky. And so if I type in help, this will show me all the list of commands that I can use on this telescope. And so imaging becomes very easy. Let me just check. Okay, hocus focus complete. Wonderful. Yes, the name of the imaging routine is Hocus Focus. So that means I can, first of all, lock the telescope. So locking the telescope means that I, as a user, have permission to use it. So that means that now I am the only one that can control the telescope and give it different commands. But what I'm also going to do is I'm going to share the lock so that we have other students here that are with us, and including Adam, that can send commands to the telescope as well. And we do that with the command share on. Hooray. Now we can open the observatory, and the command for that is \crack. So we crack open the dome. And this will take a little bit. And so, Adam, if you scroll up, there's a few other commands that I executed beforehand that I can highlight while the telescope is opening, such as \sun. And what that does is it will tell us what altitude the sun is at, which is important because we want to open the dome when the sun is at an altitude of approximately negative 15 degrees, so negative 15 degrees below the horizon. Other commands, such as clear sky, show us the weather forecast, so to make sure that we're not observing in the rain or when it's cloudy. And there's also a little webcam, so you can see what it looks like outside. And of course, the command for clouds tell us the cloud cover. Negative 17 isn't a real number, but that usually means that it's good and clear outside and we don't have to worry about the clouds. And now the telescope has opened. Hooray. And so we are pretty much ready for observing. So, Adam, what is our first object of the night?
So we are going to go to one of the galaxies in the Leo triplet. And through there, we are going to go ahead and look at those. And the one we're going to go with, M6 or 65? What do you think, Katya?
Let's see.
Let's go 65.
65? All right. So in Itzamna, first thing that we do when we want to go to an object is we have to find it. So we do \find and then M65. And so you might wonder, M65, what is this? What is this random thing? So the M in that actually stands for Messier. All it indicates is that this object is part of a catalog that we call the Messier catalog. There are a whole bunch of catalogs that exist in astronomy, like more than I can name, all with like various acronyms. And so, hooray, it has found the object. And now the next thing that we do is we plot it to make sure that it is at a good altitude to observe. So for Stone Edge, since it's in a dome and a telescope, we have a few restrictions in place. We cannot observe objects that are lower than around 3 degrees above the horizon. And so in this case, we can plot every object. And so the plot here is on the x-axis. We have the hours, so the time, all the way on the left at the origin is now, and then it's time into the future. And then on the y-axis, we have its altitude in the sky. So for this object, we see that we are observing it almost right at its peak altitude, which is fantastic. And it's actually something that we do for almost all astronomical objects that we observe, is we want to see them at their highest point in the sky, because at that point we're going to be looking through less atmosphere than if we were looking somewhere near the horizon, which is good because then we don't have as much turbulence of the atmosphere that will affect the image quality. And so that's great. And now we can actually go to the object, which we will call with the command pinpoint. And this might take a while. So now the telescope is going to actually go and physically move to the object. The command pinpoint, actually, we use it for almost everything. We don't use it for very bright objects, such as stars or planets. But we use it for a lot of deep space objects like galaxies, nebulae, clusters, etc. And the reason for this is because pinpoint is very accurate, and it will move the telescope to about the location. And what it actually does is when it gets to where it thinks it be, it'll actually take an image, a 10-second exposure of the area in the sky that it's pointed at, and it will send that image over to a web service called astrometry.net that you can honestly use if you want to. It's free, it's online. You can upload any image of the sky to it, like even one that you take with your phone, and it will tell you the exact coordinates of the center of that image. And so this helps Stone Edge exactly align the telescope to have whatever you're trying to image right in the center, which is good for us because we don't have to worry about moving and nudging the telescope a little to get it just right. Yeah. And so also while this is pinpointing, as I was saying the M, so standing for Messier, that is actually the last name of a person named Charles Messier. And Charles Messier was a French comet hunter in the 17 or 1800s. I never remember. And as he was looking for comets, he decided to a list of all the things in the sky that you should ignore when looking for comets. Because back then, a lot of things just looked like little tiny fuzzy blobs that was kind of hard to tell apart. And so he created a list that now contains 110, well, more like 109 objects. One of them is a duplicate pair. And these include a lot of what we call the faint fuzzies. So things like galaxies, different kinds of nebulae, different kinds of clusters. There's a supernova remnant in there, and then a whole bunch of other, there's a few like miscellaneous objects in there, like there's an asterism, there's a random star in there. But ironically, though Messier intended this to be a catalog of things that you shouldn't care about when observing, at least when looking for comets, this has actually become a list of some of the best, brightest, easiest to find deep sky objects, especially good for, amateur astronomers or anyone that just wants to go out into their backyard with a nice pair of binoculars, a telescope, and go look some of the beauties that we have up in the celestial heavens. And so they are very popular for things like star parties, or as Adam mentioned before, Messier marathons that are now a thing, which basically is an event that anyone can hold that is traditionally an event where it's you and a telescope, and you have to observe every single Messier object in one night. And so usually it's people starting at dawn and ending right as the sun comes up. So you pull an all-nighter and you go and traditionally you have to manually find every object. So by star hopping and relying on your knowledge of the night sky. Of course, people can adapt this in whichever way they want. We did a Messier marathon with Stone Edge, actually, which turned into more of a Messier relay. It was a good, I think, 3 nights that we did. That was fun, where we tried to image actually as many Messier objects as we could within the constraints of the telescope.
Oh, Katya, it looks like we picked something up in our image.
Indeed, yes. So Adam has, thankfully, while I was talking, taken a picture of this galaxy, just a 10-second exposure in the so-called clear filter. So it's just like a through filter, getting all the light, and look at how beautiful that is.
So this
also,
is
I think
Messier
I see a little
65.
Satellite trail.
Yes, I believe that is a satellite trail. We caught a little bit extra in this observation. I have only on a couple of occasions, I don't know about you, Katya, but I've had before when looking through an eyepiece at something during a star party, I've seen a satellite pass through the view of an eyepiece.
Yeah, I've seen it a couple times.
But so this is really cool. So now this is a spiral galaxy, and this is in the constellation Leo. And part of the why we wanted to bring this up is because Leo, as you notice, the main star in Leo is Regulus, which is called the King Star. And so this was a very important, kind of prominent constellation for the Babylonians. And it also happens to be very high in the sky tonight. And this one, this galaxy is part of the Leo triplet, which are 3 really cool galaxies that were actually all discovered by Charles Messier on the same night. And so this one is about 35 million light years away. And one of my favorite things about looking at galaxies is thinking about how long that light has taken to get to us. So with this galaxy being 35 million light years away, the light that we captured in this telescope, the photons that hit the chip in this camera, have been traveling for 35 million years. So we're seeing this galaxy as it looked back then, because the light leaving the galaxy now won't reach us for another 35 million years. And this just happens to be a very beautiful spiral galaxy. Now, Katya, would you like to grab its companion? Let's go take an image of M66.
All right, let's do it.
As I mentioned, it is the Leo triplet. The third one is named the
Wrong
the
thing.
Hamburger Galaxy, which is also just kind of a fun name for a galaxy. But that one, unfortunately, did not get a number in the Messier catalog. It just kind of got a funny name and was part of a couple of different catalogs. Now tonight we're gonna do these 2 galaxies, and then after this I have another object that is probably part of a group of objects that Katya and I are both very big fans of. And part of the reason why we're only really going to be doing galaxies and the next one is a globular cluster is because that's really all that's kind of up at this time of the year. Kind of just have to go for globular clusters or galaxies just based on where the sky is positioned right now. That's about all we can get, but you won't hear me complain because galaxies and globular clusters are my 2 favorite things to image. How about you, Katya? What are your favorites?
I really like galaxy. I like everything. Is that an answer?
I'll
Can I
accept
say
it.
I will image anything you give me, but I also am very fond of different nebulae. The ring is my favorite.
Yes, and as we move into the summer, early on in the night, the Ring Nebula will be a great one that we can go out and pick up.
Yeah, a lot of nebulae now we'd have to wait until more early hours of the morning to see. A lot of the good ones, like Andromeda, you'd have to wait until the wee hours to image.
Yeah.
So sadly we cannot do that live.
Not yet.
Yeah, not yet. During the summer it'll be great. Yeah, during the summer you also have the planets out, which is nice. Jupiter, Saturn, Uranus, Neptune.
Ooh, we are pinpointed.
Mars. Oh, wonderful.
I'll go ahead and image.
Oh, thank you.
Right. And we'll take a quick exposure of this one so that we can get a quick look at it. And once this exposure pops up, Katya, do you want to take a minute-long one, see if we pick up anything extra?
Yeah.
Right. And so we'll talk a little bit about this galaxy. And we can even compare it to the last one. And so here we are looking at another one, and you can actually almost tell that it is a barred spiral, because you can kind of see how there's a piece in the middle that it looks like it's longer on 2 sides. It almost looks like one of those like hard candies that has the twist ends. And you can see the spiral arms coming off of it. And so this is another galaxy, and as you can see when I compare it to the last one, oh no, the chart plot is getting in the way, is sometimes galaxies aren't tilted the same way. So these are great examples of how in our universe up and down is completely relative. And so some of the galaxies we look at more as a face-on view, so kind of looking at the top of this galaxy or the bottom of the galaxy, depending on your orientation, but looking kind of at the face of the galaxy as opposed to more edge on, where the galaxy is kind of turned away from us and we're looking more at it from the narrower perspective. But both of these are beautiful galaxies and have some really cool features to them.
Oh, this image. Okay, the G band has a flat filling problem, but it's there.
Oh, do we have a new image?
Yes.
All right. Let's go between the two.
It won't be as good as you think.
Oh, okay. So, Katya, would you like to take a second and explain what a filter is and why it looks like this?
Yeah, so Stone Edge, just like most, if not all, telescopes, observatories that have CCD cameras, have a whole bunch of different filters that they can use. And these filters do just what their name suggests. They filter out different wavelengths of light. And so depending on what wavelength you want, that's how you pick what filter to use. For example, if you want light that is a pretty short wavelength, so more towards the bluer end of our spectrum, our visible spectrum of light, we would image it in a filter that Stone Edge has called G-band, which is what I did in this case. There are other bands as well. The primary ones that we use are like R band and I band, which get the wavelengths for that go longer. So G is short, I is more longer toward the red side of the spectrum. I have no idea why they're called GRI. That seems kind of arbitrary. I'm sure there's an actual explanation for that. But those actually are the names come from another telescope survey called the Sloan Digital Sky Survey, and those are filters used on that survey. That is it's done in telescopes down in southwestern United States. And so different filters can show you different features of what you're trying to look at. So depending on if you're looking at a nebula or a cluster, for example, you'll use different filters for this or that. And so Stone Edge has a couple different filters. It has the GRI bands, and it also has a few narrow band filters, as we call them. So GRI are broadband, so they have like a wider range of wavelengths that they let in. Narrow band is a lot more narrow, and so we have things like the O3, the oxygen 3, the S2, and the H alpha filters. And so those basically let in different features that come in from different light that's emitted from our objects. Yeah. For example, there might be a certain object that is very visible in one band, but completely invisible in another band. And so that's why it's important to know which filters to choose from when imaging.
All kind of depends on what you want to look at. Oh, and there we go.
Yeah. Amanda. Thank you. So Amanda just posted in the chat that GRI might stand for green, red, and infrared. That would make a lot of sense. Thank you.
I almost want to make Amanda come on and use this next group of objects.
Yes. Yeah.
But
thank you, Amanda.
I know, Katya, you will enjoy telling us all about what this is.
Oh. Let me see. Let me get back to Stone Edge. I have, so many windows open. There we go. Oh,
if
that
you are
is
curious,
absolutely beautiful.
This is another object from the Messier catalog.
Yes.
So A small amateur telescope and probably some good binoculars could even pick something like this out at night. This is Messier 3. And Katya, would you like to tell us what a globular cluster is?
Yeah, so Messier 3 is what you see here. It is a globular cluster, and a globular is one of the types of main clusters, a globular cluster and an open cluster. If you go to like Australia, I think they'll get mad at you if you say globular, and they'll be like, it's globular. And they have a point there, because indeed it may look flat in the image, but it is actually three-dimensional. So it is like an actual globe or like a sphere of stars. And so globular clusters are a spherical, yes, collection amount of really, really old stars. So a lot of them are red, and these clusters are like 12, 13 billions of years old. So like maybe a year or two younger than the actual age of the universe, which is really cool.
A billion or two.
Yeah, billion or two.
Okay.
And so, yeah, super old and are all very gravitationally tightly bound to each other. And they are super, super dense, as you can see in this picture. You can like hardly tell. You can't really even resolve one star from another in the center there in the dense core. And so these actually usually orbit the core of our galaxy. So like in the halo of our galaxy. On the other hand, we also have things called open clusters, which in my opinion are a little less exciting to image, especially some of them. Open clusters are more younger stars, and they're not like very much gravitationally bound to each other. They're kind of more sparser collections of stars, and they're all born together into like one kind of family. And then after millions of years, it's thought that most open clusters kind of just drift apart, kind of like most families drift apart after like a million years. Yeah, so this is M3.
Yep. And M3.
It is about. Oh, sorry. Go ahead.
Yeah. Sorry. All I was gonna add was, this cluster is about 11.4 billion years old, and there's about 500,000 stars in the cluster. So it's one of the bigger and brighter globular clusters out there, which also helps make it one of the best ones to look at and image. But with that, unfortunately, we are going to have to wrap up. Thank you guys for joining us online. Make sure to follow us on Facebook, and if you go to our website, glaseducation.org, you can sign up to be part of the email list so that you don't miss any of the notices about these shows. But you can count on, at least for the next couple of weeks, if not months, we will be doing these shows every Friday night. And each week we'll be bringing a different theme and talking about something new each time. And as we slowly progress throughout the year, all of the objects we'll be looking at will then be a little bit different, and we'll try to make a good variation of objects as we go through to make sure that you guys have a reason to keep coming back. But with that, thank you guys all for joining us, and have a wonderful night. Katya, is there anything else you'd like to say?
No, just have a good night, and thank you again for coming, and we hope to see everyone next week.
All right. Have a good night, everybody.